Math 2415, section 10.7, vector functions. Vector functions, parametric equations, eliminating the parameter. What you see on the board is mostly what was on the board at the end of the previous video. We had a vector function. I erased the red stuff under here. We generated some vectors by choosing values for the input, which is also called the parameter. We went from -3 to 3 and generated these vectors. I originally drew all the vectors, but it got a little bit messy, so I erased them and just kept their terminal points. And then we labeled at what value of the parameter, which you can think of as a time measurement, at what time were we at certain points on this parabola, and then we drew the arrows to indicate the direction the point was going as time increased, called the orientation of the curve. And it ends up being a parabola, which probably didn't surprise you because there was a square over here. In fact, this is a parabola that you may know the equation of, not from a parametric perspective, but if I said, give me an equation using y's and x's, what's the equation of that parabola? You can sometimes, I don't want to say more times than not, but sometimes you can take a vector function and come up with a we'll say rectangular equation in x's and y's. In other words, an equation that's not that doesn't show the t, that's independent of t, that gives us the corresponding graph. This is called eliminating the parameter. As far as the parametric equations for any space curve, if you know its vector function, can be obtained by simply looking at the vector function's component functions and setting them equal to x, y, and if necessary, z. In this case, the parametric equations for this vector function are just x equals t minus 1 and y equals t squared. X component, y component. But to eliminate the parameter means to take this, if you will, system of equations and eliminate the t. So if you look at it from a system of equations perspective, what can we do to make the t disappear? In other words, what could we do to eliminate the parameter? To eliminate the parameter, we could, and we will, solve one equation for t. Now this isn't the only way to eliminate a parameter, but this is pretty straightforward when it's possible. Solve one equation for t, and then substitute. So for example, I'm going to solve one of these equations for t. I think the first one, the x equals t minus 1, is a little bit cleaner. The other one I would have to square root, break out a plus minus. Not sure if we want to do that. But if I take x equals t minus 1 and solve that for t, that implies that t is equal to x plus 1. But what does that imply? That implies if I go to the other parametric equation, I can replace the t with x plus 1. So this implies that y is equal to x plus 1 squared. And we've successfully eliminated the parameter. And if you remember about basic functions graphs and translating them, you would probably know that this is the equation of a parabola that's been translated to the left 1, which is precisely what that is. I'd be lying if I said eliminating the parameter from a set of parametric equations is always this easy and this straightforward. It sometimes is, but sometimes you have to do a little bit more, let's say, hand waving. In the next video, I'll show you another vector function where it's not so obvious how to eliminate the parameter, but it will be a common way to eliminate a parameter because we're going to run across it a lot.